Now that we have learned, yesterday's seminar covered sampling, actually field sampling, sampling techniques, and now that we have covered the sampling aspect, today we're going to talk about the documentation you need to get your samples into the laboratory system, analysis selection, and shipping of samples. So we're going to start off with the documentation, and Ellis Benham, Larry Arnold, and Henry Ferguson are gonna cover the other topics. So submitting soil samples. As I said yesterday, we talked about the actual sampling techniques. Once we have the samples, the next step is the documentation and submitting of the samples. And then finally, we'll talk about the actual packaging and shipping. The documentation, we have spreadsheets that are specifically designed for the documentation. We're going to cover that, and part of the documentation is also NRCS. So part of it will be populating these PEDONs in NRCS, and then also after submission, maintaining the PEDON information in NRCS that goes along with the analytical results. Okay, to download the most up-to-date version of the sample submission documents, this is the link. And if you're like me, you would never be able to copy that down and type it into your computer without a mistake. So alternatively, I'm going to show you a three-step way to get to these, to download these sample submission sheets. Start off at the NRCS homepage, nrcs.usda.gov. Okay, then up on the blue menu bar under Topics, you're going to select Soils, and that's going to take you to the Soils homepage. That may be your homepage anyway, but go to Soils homepage, and again go to the Topics button on that blue bar, select Technical References. That'll take you to this page, Technical Reference page. Scroll down about the middle of the page to Laboratory Methods and Information. Then right at the bottom you'll see Soil Sample Submission Worksheets. Click on that and it will take you to this page with the zip files, which you can either open and save or download to your computer. So these are the files you're going to want to go to. This will always have the most up-to-date sheets. You'll notice that one of them was updated 4/15. So you know, unless you sampled fairly recently, probably the best way when you're submitting samples is to go directly to this page, download the forms, and then you'll be sure that you've got the most up-to-date forms. Okay, once you download those and open them up, there's going to be two separate spreadsheets. One of them is the project sheet. There'll be one of these for each project that you submit. And as a note, what the lab refers to as a project is a group of samples that are submitted at one time. In other words, we'll get a shipment in, it may be one PEDON, it may be 3 or 4 PEDONs, but all the samples that are submitted with one shipment, we refer to as a project. And that may be somewhat different than, let's say, a NRCS project. But from the lab's aspect, a project is a group that is submitted at one time. So the project name would be the name you want to put on that. It might be Eastern Nebraska Benchmark Project or whatever that might be. Project submitter phone number, and this is for contact, and primarily that's what this sheet is for, is to give us the contact information. So the phone number of the submitter, the MO, that probably is should be regional office number, your NSSC liaison or project coordinator. So for a characterization project, this would be your liaison. If it's another special project, for instance, let's say a DSP project, then it might be someone else. But this is essentially the person at the NSSC that is going to kind of be shepherd this project through. The leader, submitter, again, that's the same person that we put the phone number up there. Soil data quality specialist, state soil scientist, or RO leader, and then others. So if there are, for instance, university people cooperating, these are the people that are going to receive the lab data once it's done. So again, we do one of these sheets for the shipment. Okay, now the next spreadsheet you're going to open up is the sample submission sheet. It's got two parts or two tabs. And notice this is an XLSM, so it's a macro-enabled spreadsheet. The first page is going to be the pit-on field sheet. This is what similar to the sheet that's been around for years. It was blue, so it's called the blue sheet or the pit-on sheet, the paper sheet. So this is the version of the pit-on sheet that we're going to fill out electronically. Notice up at the top there's an enable content. So for this to work, it is macro enabled. You need to click on that button to allow that to work before you start filling it in. Notice also it says mouse over shaded cells. So you'll notice the shaded cells have a little red triangle in the upper right hand corner. If you put your mouse over that, they'll drop down list or explanation will occur, will come down to explain what that is. And then notice down at the bottom there are two other tabs, request for analysis and direction. So the request for analysis sheet is this sheet here, which you'll actually request which analysis you need on each horizon. And Ellis Benham's going to go over this in a little bit more detail a little bit later. Then we have our instructions, and a lot of this is covered in the drop-down menu. So if you'll take advantage of the little red triangles, then you can get most of the instructions you need from that. Okay. Now, as we said, these are macro-enabled and they're linked. So as you fill out the pit-on information on this, the horizon depth, the designation, it's going to automatically populate this sheet, as we'll see. So that's one of the things that the macros do in this sheet. So this sheet is what allows us to enter your pit-on information in the laboratory information system. So it's going to be the information that accompanies your analytical information through the analytical process and when the information comes out. And this is going to serve as what we call the sampled as information. It's the information that was correct at the time you sampled that. And as we know, some of this, for instance, the classification may change based on the results of the analysis. So that information is going to be, you're going to be able to change that through NRCS, through your pit-on in NRCS, your lab pit-on in NRCS, and that's going to be available for the submitter to change themselves. So that's going to be the responsibility of the sample submitter to keep up with and maintain. Henry Ferguson's going to touch a little bit on that later. So the information we need on this sheet, soil name. Normally this is the soil series. This is going to go into the database, and when people query the database for a certain soil series, this is what's going to show up. Some cases it might be a higher taxonomic name, but this is the basic identifier you want to go with that soil. User pit-on ID. This is a very important piece of information. This is the NRCS user pit-on ID, and it needs to conform exactly to the format for that, which is also in the red pit-on description book. The letter S for sampling, the year, the state abbreviation. The next three are the county FIPS code, and the final three are the sequential number of that pit-on sample of the number of pit-on sampled during the year. The county code is especially important because that goes into the lab information system and allows whoever's logging your sample in to determine if this is APHIS regulated or not. So that's essential that number be in there and it be in the right sequence for them to get that information. Sample date is actually the date with which it's sampled. Taxonomic class, again, that's going to be what you put on there is going to be the sampled as, serve as the sampled as. Location, WGS is preferred, and then in the format of degrees, minutes, seconds. And again, it's with the seconds, it's important to have at least one, preferably two digits there in order to get a precise location. Control section, that's going to be, you're going to enter that in, and that's going to be what, when your data comes back, there are several things. For instance, the particle size that's calculated as a weighted average for the control section, information you're going to need, and if you don't put the control section in there, that's not going to come out on that sheet. MLRA code is the your MLRA code. SSA soil survey area. In a lot of cases, that's going to be a county, but in some cases, it might be a multiple county area. So you need to make sure that's the soil survey area code. Finally, the NRCS record ID. That's going to be, of course, the number after you enter your PID-ON information in NRCS. That's going to be the number that's out in the last column in NRCS. That's important because that allows the lab to find that PID-ON and get the PID-ON information. But also, you should submit, once you have entered that, which you need to do before you submit this, once you've entered your PID-ON, run the PID-ON report, print the PID-ON description out, and include that with the samples. Okay, so now, actually the sample information is down in the spreadsheet. It's going to be one line for each layer or horizon. First one, field number, and this is what Phil talked about yesterday. It's the sequential number of samples in the project. You know, we said the project is the group of samples that you submit together. So this one we have, this PID-ON, we have six layers. If and those field numbers are 1 through 6. And you're gonna have a separate PID-ON field sheet with each PID-ON. So if you have another PID-ON in this, it's going to be another sheet, and that sheet's going to start with number 6 in that field number. So your A horizon on the second PID-ON will be 2, the second one be 3, 4, 5, 6, etc. So if you ended up with 12 samples in your shipment, you'd have 12 field numbers. And again, that helps track the samples. It helps the people that log in to account for all the samples, and if there's any confusion, it allows them to get them in the right sequence. Depth, horizon depth. This one, if you'll just populate the bottom depth column, it will auto-populate the top column. The horizon number is already populated. Horizon designation is your standard horizon designation. Field texture, abbreviation for the texture you determined in the field. Quantity of samples. This is the number of each type of sample that you include for that layer. Normally, your bulk sample is going to be 1, but you know, as was discussed yesterday, if you have a very high fragment or a low bulk density like an organic, you may actually do 2 bulk sample bags for that layer. So in that case, you'd put a 2 there. Bulk density clods are the clods you submit for bulk density. Normally, there will be 3 of those. The natural fabric clods are the clods that have the tack or the staple in them to indicate the orientation of those, and those are submitted for the thin sections. The other types of samples, these would be compliant cavity, a known volume can, or a ring or core. And these are the cores that actually where you would use the core to take it and only send the sample in, not the whole core. It's not a true core, but it is one taken with a ring.
Steve, can I interrupt you?
Yeah.
There's a question here. Could you say that again about the field numbers?
Okay. Yes. Okay. The field numbers. Again, this is a number that goes. It's going to go. If your tags, when you get the pre-printed tags, you'll notice there's a place on there that says field number. It's also you're gonna write it on the bag, and then you're also gonna put it here in this first column. It is the number of, it's gonna run 1 through whatever number of samples you have. If you do 3 PID-ONs with 8 samples each, 8 layers each, you'll have 24 field numbers. This is the first PID-ON. So your field numbers go 1 through 6. If your second pit-on had 6 horizons, it would be 12, 13, 14, 15, 16 on the second pit-on sheet. This allows, in looking at this sheet, for instance, if there's a sample submitted and it's not clear, something like the horizon depth, or it's not labeled properly, or it looks like it's out of sequence, then the people logging this in can refer to this field number and put them in the right sequence. And so it's a double check for the labeling and that these samples are in the right sequence. And that's what the field, it's not, the word field is a little misleading. It maybe should be layer number or something like that, but that's traditionally what that has been. So it's actually the number of the layer or horizon in the sequence of the whole pit-on. Does that cover?
Second pit-on would start with 7.
Oh, okay. What did I say? 12.
12.
Okay. Yeah. Right. Yeah. You start. Second one would be 6, and then go through 12 if you had 6 in that one. Okay. Yes.
You might also mention that if you move from one county to another county, but it's still part of the same project, you would continue sequence of field numbers.
Right.
Don't start over if you change counties.
Okay. So yeah. So that's it's the sequence for the entire shipment. So it doesn't matter if you do different pit-ons, different counties, different locations. That follows the sequential number for your horizons. And a lot of people have not done that. I think it's largely because they don't understand, but it's on it'll be on the tag, and you fill it on the tag, write it on the bag, and then also here in this column here. And that's a fail-safe for making sure that they're labeled right and in the right sequence, and in helping the people that unpack it to actually make sure they're all there and arrange those for logging in. Okay, so now we were talking about the core samples or compliant cavity. So we've got one. This may have been, for instance, a very fragile, very friable horizon that you couldn't take a clod from, so you did bulk density on it. So there's one bulk density sample. And those type of samples must have a volume because they're not standard. So when you did compliant cavity, you determine the volume. Or when you did a core, you had a standard size core and you determine the volume. So that's where you put the volume. If we don't have the volume, we can't do bulk density. So it's essential that you put that volume there.
Steve,
yeah.
Got it. So just for clarification, if you were had a second pet on, that first horizon would start with field 7 in this example.
Right.
Okay.
Right. Yeah, I'm sorry, that was a mistake. I'm glad you caught that. So yeah, each number, it'll be a unique number beginning with 1 on each layer. Okay. All right. Finally, our weight of fragments. The remainder is weight and volume of fragments. The first 2, weight in pounds or kilograms, these are going to be calculated as a percentage, so it really doesn't matter as long as you use the same units for each one. And this is what you're going to use the sieves for, the sieves that you have in your sampling kit. You're going to sieve out the sieve out the fragments, weigh them, and write the weights down in there. So from this, we can determine the percent less than 20 versus the percent 20 to 76. And again, this is on the weight basis. Now the remainder of the columns are going to be volume of fragments, and this is going to be estimated. There's no other way, especially when you get into the large fragments. And this was maybe mentioned yesterday that if, for instance, if you have fragments that are 5 inches in diameter, you would have to have a weight of several hundred kilograms to actually get an accurate weight estimate of the fragments. So this is what you're going to do. You're going to do a visual estimate of this in the field. And this is the only place we have to get this information. So again, a lot of people, or times people don't fill this out, but if you have fragments to get the information you're going to need to interpret your results, you're going to need to put that in there. The first two are the percentage of the whole soil of fine gravel and then of medium gravel. The other ones are going to be the percentage estimate of the various Channer or stone classes. So they're up at the top of the column. If it's a flat fragment, it'll be a Channer. If it's a rounded fragment, it will be a gravel. So that's the estimates you're going to put there. There's one that we were saying, field number 6, horizon number 6, had some fragments. So that's what a fragment estimate might look like filled in on that line. So again, that's an essential. That's one of the things that a lot. Yes.
You might mention that those are the only classes you can enter in limbs, those boundaries. You can't do a la carte. Like
oh, okay, right. As in that, yeah. These are fixed size ranges. So it's no. You have to use the range that's up there. So you're going to have to estimate if there are none greater than 25, you don't put anything there. So again, those are fixed classes, and you can't change that. Okay, so that's our PET on field sheet. So if you have populated the horizon depths and designation. And again, at the bottom of this, it doesn't show, but there is a place, reason for sampling, and this one was representative PET on or benchmark. It might be DSP, or it might be soil quality, or it might be to determine the break between two different series. So that allows the lab to determine help determine what analyses are relevant and make sure that you get the analyses you need. And there's also a notes local PET on, so you could write some additional notes down there. For instance, if some of these samples you're going to submit, you want a moist particle size on there, you could mention something like that. That a certain layer the samples are moist and to be used for moist, or so they may be pre-sieved or pre-dried. So things like that you could mention there. Okay, so now we're going. The next sheet is the analysis sheet. So as you see it on the left there, it's pre-populated. Your layers, your PET on ID, your field number, your horizon, and top and bottom depth. So the next task is to select the individual analyses or group of analyses that you want for the sample from each of those layers. So Ellis Benham is gonna discuss this, and I'll let him take over at this time.
There'll be a little bit of overlap here. Okay. Steve mentioned, and I'll reiterate, you have to enable macros to get this to work. Click that button. Now then, there's a little bit of help available. As Steve mentioned, the cells that have a red triangle in the upper right corner have a drop down if you mouse over them. And this is an example of the analyses that you will get if you check salt in one of the layer boxes below. Similarly, for each individual analysis out there, it lists the analytes that you'll get back. And the analysis groups are all over at the left side. It's suggested that you use one of those and then add additional analyses. The reason for that is these analysis groups more or less mirror the limbs analysis groups that I use to really select analyses in the database. And there are some things that are not on this sheet, some analyses that are not on it, that are required for us to run the samples through the lab. And so they live in the background, and if you check one of these, I will mirror your check mark into the lab analysis system, and that will keep things synchronized there. So the general procedure is on a layer-by-layer basis. Check an analysis group unless you have grab samples that you only want a couple of analyses on. Check any additional analyses that you want. And if there are some that are not on this sheet that you know you need, type them over in the rightmost column for the spreadsheet. And this shows up as the little check boxes, arrow pointing to one here in the analysis groups. And when you check one of those, you get a batch of a varying number of gray check marks in the area to the right. Blue arrows pointing at a few of those. You can't remove those by clicking them. They're just there. If you want to add additional analyses, you can check the boxes out there yourself. Yellow arrow points to a couple of those. Those wind up with a black check mark in them instead of gray, and if you click them again, the check mark goes away. And then for those things that you need to write in, the wide arrow at the right out there allows you to do that. And just because an analysis is not on this sheet, if it's listed over there for the analysis group, you do not need to write it out in the right column. Now then, we have in the lab a request versus resources issue most of the time. The total requests typically exceed our capacity. This is not necessarily all of the requests coming from the MO. We get projects in for other agencies, special projects in other areas of NRCS, cooperators, etc. But in the end, we're swamped. Right now, technician FTEs are the limit on analytical throughput. There's nothing much we can do about that. The number of people is controlled from elsewhere. So the next few slides cover situations where we may ask you to consider adjusting the type or quantity of your analytical requests. And just a note, we sometimes add a few analytical requests to those that you send in. We're trying to facilitate the use of the data for other purposes, examples, building models, at a later date. In other words, we're trying to get a data set that allows reuse. Now, first thing is requesting analyses that are inappropriate for the material. Some examples here are PSDA on O horizons. That was mentioned yesterday. Clay mineralogy on O and A horizons typically isn't of particular value. The results are somewhat compromised by weathering and the amount of organic matter there. Clay mineralogy, if the soil is less than 1% clay, it would require such a large sample to get a clay sample to run through the X-ray that it just doesn't work very well. Grain counts on O horizons, again, it's not a particularly good idea, and the material is difficult to separate and difficult to identify. Grain counts, incidentally, come from sand fractions or silt fractions separated in the PSDA analysis, so you don't have it to start with on the O horizons. Next one is clod bulk density on horizons that are coarser than a sandy loam. Those were mentioned yesterday, the clods are going to fall apart even if you collect them in the field. Before we get them sliced in here and put on the tension tables, they typically disintegrate. So for those horizons, coarse textured horizons, use one of the compliant cavity methods. Water content at tensions less than 2 bars on sieved samples if the texture is finer than loamy sand. In these, those low tension water amounts the procedure we use results in uncontrolled expansion of the sample, and the water results that we get are going to be far higher than anything that would ever be seen in nature, so it's not of particular value. Those samples depend on the structure to confine them when they're at low tension, and you have no structure left once you've sieved the sample. And New Zealand phosphorus retention is inappropriate on O horizons. That was mentioned yesterday. Another analysis that is inappropriate for the material is fiber on other than O horizons. You don't have enough fiber to argue with. Glass counts on other than volcanic influenced. And a note here, running peaty, mucky, similar high organic materials requires the soil solution ratio to be changed for several of the chemistry analyses, and the results may not be strictly comparable. What is happening is that a soil solution ratio intended for mineral soil has to be changed to add quite a bit more solution because the organic material soaks it all up and you've got nothing to analyze. A few comments on phosphorus. Phosphorus will be one of those things we add if you don't request it for the upper horizons in a bed-on. Olsen phosphorus is only appropriate for calcareous systems. Malic is most appropriate for acid systems. It's of limited utility in calcareous. If I know nothing else about the layer, I'll request Malic on it. It'll give you some kind of information under the broadest range that of any of these tests. Bray phosphorus, if you have prior Bray data and want to continue, request it. Otherwise, it's an older method and it is less forgiving of conditions outside of those it was developed for. And phosphorus analysis is typically requested on the upper 50 centimeters of a peton. Some analyses are needed for selected horizons. We're thinking usually in terms of classification, and these are high labor analyses, and we don't want to run them on every horizon in the peton. One of those is clay mineralogy. We'll run something typically out of the control section and maybe run another one if we have a parent material change. Similarly, the grain counts are optical. We suggest one out of the control section, usually upper control section, and then possibly another if we have a parent material change elsewhere in the profile. Grain counts on more than one size fraction are strongly discouraged. Grain counts are very slow. It's the slowest analysis we have in the lab. We have fewer people who are qualified to do those than most of the chemistry analyses, or physical probably. So it uses a lot of that technician resource that we're already short on. If you're trying to push glass amounts in the direction of higher glass, you want it run on coarse silt. If you're trying to push the data in that direction for some reason. As the fractions get larger, coarser, the glass amount drops off. And left to our own devices, we will look at coarse silt, very fine sand, and count the one that is present in the greatest weight percentage. For fine clay, we'll run it on a BT and an overlying horizon if requested. We would rather not run it on every horizon in a PEDON. There are some analyses that are frequently requested and only occasionally useful. One of those is field water content. Frankly, it's hard to say what you have when we run field water content here. You have what's in the bag at the time we get around to analyzing it, which may not be particularly closely related to what you put in the bag much earlier. The bags aren't exactly vapor tight. They may sit around on the shelf quite a while before we get started on the project. So there's, at least I have a general question of what it represents, how it's used. X-ray of powdered whole soil. This one is a ground sample run as a powder, not oriented. It doesn't tell you the clay. It gives you some information about the silicate minerals that are present, or well, other minerals for that matter, if they have an X-ray signature. But it gives you all three axes, so you have a forest of peak locations, many of which are very close or overlapping. It's not particularly useful for anything that we normally do. Thin sections are useful for some information. There's not a good way to get some of the thin section information otherwise, but thin sections have always been interpreted by the research scientists as a function that was related to sample requests coming from their area. We have far fewer people who are willing to try to interpret them now, so we can still get thin sections made eventually, but getting them interpreted here now is a big problem. And APHIS requirements on thin sections have resulted in us having to cook the regulated area clods before they're sent off for thin sections, which disrupts some of the morphological information you could get from them. So it's hit or miss these days. It's not like it was 15 years ago. Moist PSDA is another analysis that's requested more often than it's relevant. It is only preferred in materials that change irreversibly on drying, meaning they haven't dried in the field in the last umpteen decades. And there are some areas in Hawaii that are like that, but for most soils that occasionally dry, there is no benefit to running a moist PSDA. In fact, it's probably a little less repeatable than the dry PSDA. Now, there are some analyses that depend on other results as to whether we actually run them. They show up in a request for you, but you may not get data back if other analyses indicate that the material is inappropriate for that test. One of those is carbonates. We don't run it unless effervescence and pH indicate there might be some carbonates there. KCl, aluminum, and manganese is run based on calcium chloride pH. Saturated paste is run on a EC predict basis. Carbonate clay run on effervescence. Extractable acidity is run on an effervescence criteria. And gypsum is run on an EC or a predict criteria. I think that's all. Larry is going to talk about some shipping and other things, I guess. Move it on. These two arrows right here, forward and back.
Okay, I'm Larry Arnold, and I want to give you some other considerations about the samples before you send them in. And the big one that we're going to talk about is APHIS and Nebraska Department of Agriculture. They do have some restrictions on soil samples that come from certain parts of the country that are quarantined by those two government agencies. And so we've made it easy for you guys out in the field as far as how to know if you have, well, you don't really need to know unless there's samples that we cannot receive. But it's also good to know if you do have quarantine soils, there are some that we can receive and some that we can't. But the most important one that you need to know are the ones that we cannot receive. So we're going to talk about, I'll show you specifically the ones that we can't receive, and I'll mention the ones that we can receive. But there is a document in the soils website. When Steve went in and showed you where the documents were for sample submission, right above there is a document that's called Soil Sample Submission Protocol for the Kellogg Soil Survey Laboratory. This is something as sample submitters that you need to really become very, very familiar with, because it does give you step-by-step, very precise instructions on who we need to contact in case their samples come from certain areas, which I'm going to identify to you here pretty soon, and how to pack the samples, ship the samples, and prepare the samples before they're shipped. So if you have any questions about any of that, you can contact Rich Ferguson, who's our permit holder, and me, because I'm the one that sends out all the equipment, and I keep track of what counties are quarantined and regulated, because it is updated continuously by APHIS especially, and I'll show you about the ones that are from the Nebraska Department of Agriculture. So I wanted to just show you the samples, or the areas of the country where we absolutely cannot receive soil samples from, because these pests may be in the sample. And there's two counties in Idaho. One is Bonneville County, and the other one is Bingham County. And you can see where it's marked red. Those are the specific farms and areas where there are quarantines that we cannot receive samples from. And so if you're going to be sampling in that area, make sure you check with the local APHIS people to make sure that you're in compliance where you're sampling, because those we cannot receive in those red areas. Other areas we can, but we just need to verify that you're not going to be in those red areas when you're sampling. Another area of much larger area that's where we cannot receive soil samples from is along the coast in California. And you can see the counties that are listed there. Those are complete counties in California, and also in there's a little partial area of southwest Oregon right there. And it'll be the same thing in Oregon. You need to check with your local APHIS people to make sure you're not sampling in that particular area. We absolutely cannot receive samples, and it's because of a Phytophthora ramorum, which is a disease of oak plants. And I've just heard recently that that's spreading a bit more quickly across the United States than what they previously knew, and so this could be a bigger issue in the future. And another area where we cannot receive soil samples from are the fruit fly quarantines that are in effect. The good thing about these quarantines is that the only area affected is under the drip line of host plants. And so you can see that there's a Mexican fruit fly quarantine in Texas. There's Oriental oriental fruit fly quarantine in California and Florida, and so same thing. You need to check with your local aphis people before you sample in those particular areas of those states to make sure that those are not under the drip line of host plants, and then that they're not in those quarantine areas. And this particular quarantine comes and goes. It's the and sometimes they'll take the quarantines off, and sometimes they'll add new ones. And so these are considerations that if we and in the document sample submission protocol for the Kellogg Soil Survey Lab on page I believe it's on part 1. There's a page in there that tells us exactly what areas of the world and the country that you cannot sample from or send samples in without first checking with us. And so any foreign countries, any U.S. possessions from overseas, and those that we've listed, the counties that we've listed in that document are. And so I would recommend that before anybody samples any soils, if they know that they're going to be in quarantine areas, is to look up that document and become totally familiar with it. Not only does it tell us where we can't sample, but it's going to tell you exactly how to pack the samples, label the samples, and ship the samples, so we're in compliance with the APHIS compliance agreement that we have with APHIS. So proper labeling, packaging, and shipping are critical to your success and our ability to fulfill your expectations. And so we've made it easier for you guys to not have to determine which ones we can receive samples from. But just so you know, we can receive from quarantines in the south and southeast part of the United States for fire ants. We may receive samples from quarantines in New York State for golden nematode. Witchweed's another one that we may receive samples in from South Carolina and North Carolina. And then the Nebraska puts a quarantine in effect for the western part of the United States, which lists the whole states of California, Idaho, Oregon, and Washington, and then specific counties in Colorado, Alamosa County, Conyos, Costilla, Rio Grande, Sagauchi, and then Nevada, Humboldt County, New Mexico, San Juan County, Texas, Hartley County, and Utah, Iron County, and Weber County, and Wyoming is Laramie County. But we may receive samples from those areas. I'm just giving you that information. But as far as shipping the samples in, we've made it a uniform protocol. So whether it's quarantines that we may receive or it's non-regulated soils, we ship them all the same way. And so it's required that every sample that comes in be shipped the way that we're gonna that's in the document. And I'm going to show you some pictures of some documentation of how we pack them. So be sure that we provide you with everything you need for labeling, packing, and shipping, except for you guys need some good packaging tape to tape up the boxes and the markers that you use to mark. And like I said, we follow these directions regardless of whether it's regulated or quarantined. And we will arrange for the shipping via UPS, so you don't have to worry about them getting shipped in. We'll arrange to send you UPS labels, and you can contact me or Steve or Michelle Ettman or Pam Van Ness, and they'll be able to help you with shipping. So here, I'm just going to show you the proper packaging and preparing of the samples. You can see this is a tag and a bag, and then we have a stapler that we would send in our kits. We've listed all the requirements on the tag and the bag. we got the soil series, we got the horizon designation, the user pet-on ID with the layer number, the depth, and then that field number that Steve was talking about. And these bags, just so you know, we want you to ask us for the bags. They're 8 mil bags. Your typical bags that you might buy to put soil samples in, like Ziplocs, maybe 1 to 4 mil. These are 8 mil, so they're a lot heavier. And they'll help keep us in compliance, or they do keep us in compliance with the APHIS. And then a pet-on's worth of samples, bulk samples like you see here, would be put into a secondary container, secondary liner, and we'll send those liners out when you request supplies from us. So if you're not requesting supplies and you have your own out in the field, make sure that you're contacting us before you ship them in, because you can't ship them yourself. You need to contact us to ship them, and then you can visit with us, and then we'll let you, and then we'll ask you if you have the compliant shipping materials, and then we will, if you don't, we will provide them to you. But this particular secondary container needs to be put into a box that we're going to provide to you. You can put up the, you know, I would recommend about 50 pounds worth of samples. Make sure you have a complete pet-ons in the bag so we don't mix up pet-ons in bags and boxes. Here's the box that we will provide to you. It's an 18 by 18, 12 box. It's heavy-duty, triple line, designed for heavy-duty use. And so you'll put that secondary bag with those primary bags inside the secondary bag into that box, and that secondary liner is also 8 mil. They're special ordered. You can't order, well, I guess we can order them from one company. We used to have to make them do special orders. But then during shipment, we don't want those samples to jostle around and move around, because some of the workers in the shipping companies tend to toss boxes around in trunks, and so we want to fill all void spaces with paper or packing peanuts or something like that to avoid shifting of the contents during shipment. And then this is where you'll need some heavy-duty packaging tape, which we won't provide to you, but we need to seal up that box. And then once you have the weights and the dimensions, well, we know the dimensions, it's 18 by 18 by 12. If you give me a different dimensions, I know you have the wrong box. We'll catch you. So that's the bulk samples. And then on the clod samples, we're going to do what we typically do and put those in clod bags, which we'll provide to you. And those aren't as heavy duty, so don't worry about them being 8 mil, because they wouldn't fit in the cells if they were 8 mil anyhow. But we need to seal them shut with twist ties and put them in the appropriate cells. Let me go back. I don't know if I thought I had a picture here of a properly labeled clod box, but I guess that's in another document. Somebody asked about that yesterday, and I was hoping, but this one you can see, for a properly labeled clod box, you need to have as much information as you can, but at a minimum, like I said yesterday, the user pet-on ID with the layer number, and then if you can get the horizon designation and the depths in there, that would be great too. But make sure that you're sealing it up with twist ties that we'll send, and then make sure also if there's any empty cells in that clod box, if you haven't filled it up totally, that you're filling it up with paper material or packing peanuts or something like that. And then we put a layer or secondary layer or a bag around the clod box, and we will provide you those, and that's part of what we do. If you just make sure make it apparent to us that you're going to take clods as well as bulk samples, so we'll send you that stuff. But these are light bags, and so if you have heavier, bigger trash bags, you won't be able to pack all your 6 clod boxes into a clod trunk. And here's the next picture of the clod trunk with 6 clod boxes in it. that are all have liners on them. And so this is the required shipping protocols that we have that's in the document that we must use those protocols and ship them and pack them that way just to keep us in compliance. And that way we don't have to distinguish between regulated and non-regulated areas. Regulated, of course, being the ones that we can receive, and I identified the ones that you can't receive. And so if you have any questions about that, talk to Rich Ferguson or talk to me, making sure that we are able to receive samples from those areas if there's any questions about it. So that's all I have. We have Henry Ferguson now, and he's going to finish it up. Then there'll be questions.
How do you, are they after this slide?
Yeah, right. You should start.
There you go.
Yeah.
Okay. So from yesterday's webinar and today's, you probably noticed the theme that these samples pass through several people. From the time you get in the pit until the time you get your results back, at least 5 different people have been involved in putting some kind of documentation on your samples. And during those, when you pass paper from one person to the next, there's always a possibility of mistakes being made. So one thing that we're trying to do is we're trying to figure out how to streamline the process and get the people that are actually sampling the soils to be more involved in inputting more of the data in NRCS so that we can keep things a little bit more streamlined and maybe remove some possibility of error. So one thing that we did in the last few months is we added some new columns to the Pet on Horizon sample table in NRCS. The kind of columns that we added include the depth, top depth, bottom depth of the sample, the number of bags, density clods, fabric clods, and other samples. It is encouraged that whenever you sample, if at all possible, that you actually sample the entire horizon and you use the top and the bottom depth of the horizon for your sample depth. Just because we added depth to the sample table doesn't mean that you should be, experimenting with sampling at different depths. Whenever possible, you should sample the entire horizon. Just because we add a few more fields to NRCS doesn't mean you're going to fill them out. Not for all those old projects you did in the past. Don't worry about those other fields, you just ignore them for now. We did put these fields in because we're hoping that in the future we can come up with a system that's a little bit better for submitting that paperwork. When you actually look in NRCS, you'll find that all those little fields are squeezed down so you can't even read the headings, so you have to stretch them out so you can see the headings. So in the process of doing that, right today, before we get this new process working, it still is critical that you populate the sequence number. Notice that these sequence numbers go 45, 46, and 47. So this is a good place to practice putting those sample numbers for your project in, so you get used to doing that. The field number normally is the user pattern ID with a horizon number after it with a hyphen. And then there's always a top depth and bottom depth. For those folks that are using the NCSS lab layer table, which has the same depths that are in this table, you'll notice that the top depth and the bottom depth are required. So if you don't want somebody fabricating a bottom depth for your last sample, you should always put a bottom depth for every sample that you take, even the last one, because those depths are required. So if it's not there, somebody's going to have to make one up or it won't get in the database. The goal is that in May or June or so, NRCS is going to come out with a form-based data entry. That also means that you'll be able to look at the data that you've entered on a form. So at that time, we're hoping to create a form that looks exactly like the paper sheet that we've been asked to submit to the lab, and you'll be able to bring your data up in NRCS and review it in that sheet format and print it out. So it's nice and clear and legible. Because remember, I said
There's 5 people that are going to have to look at that sample. The people in the pit, they write it on paper. You hand it to somebody else in the office, and they type it into NRCS. Some of the data ends up on paper, goes downstairs to processing, and they type it in. And then Scarlett puts the lab sample number on it. And then Ellis inputs the rock fragment content. So in the process of all those 5 different steps of putting that data in, there's a great possibility for inconsistencies. So if you type your data into NRCS, review on this form, submit this form, and in the future we'd like to even have a download straight out of NRCS that we'd upload into the other database. And at that point we take several of those steps out of the equation and there's less chance for error. The only 2 fields that are not in NRCS right now are the bulk sample weights. So you have to print out the form and write those in. And this sort of goes along with the theme that we've been working on for the last few years, which is trying to get the field to take responsibility for their own data, their own descriptions, and then we data mine any changes that the field makes to their horizon designations, taxonomic classifications, or locations from the database. And that's it for my presentation.
All right, let's have some question and answer period. I know we've gone just beyond an hour, but I think these are important questions that people have submitted. So Steve, if you'll go up and move to the PET on field sheet in the presentation.
There was still some confusion about
quite a few, yeah. So let's get that cleared up.
Okay. Will this like start from beginning?
Yeah. You can grab whichever slide.
That's the first slide.
Okay. Let's go to that.
And I'm going to put it back in the regular view.
Okay. Here. Okay.
All right.
Okay.
So first question is, I have a project in NRCS for sampling 8 PET-ons this year. I'll be sampling throughout the year, 1 or 2 PET-ons at a time. I would likely make 4 shipments to the lab during the year. Would I not use the NRCS project name and start over with field numbers with each shipment?
Okay, you can use the NRCS project name, but it's going to, like we were saying, every time you send a group of samples in to the lab, it's going to be considered a new project. So what you might do in the on the project sheet where it says project name, you could put the NRCS project name and then maybe put shipment 1, shipment 2, and that way you could keep up with it, but then the lab would still be able to put a unique name on each project for our purposes. But just the way the lab data management and the project completion and the data dispersion works is that when a group comes in, it's logged in, it moves through the lab at the same time, it's completed at the same time, so that's kept, and the data comes out at the same time. So for our purpose of the project, it's going to be it's going to be several projects, but if you can put for your project name some way, just number 1, 2, 3, 4 to break that up, but still have the overall name, that might be a way to handle that.
Now back on that user PET on IDs, several people commented on that. I need you to go over that one more time.
Okay.
You're asking for the one page that has the number populated.
Okay. Let's see where that's more. Oh, here.
Yeah.
Okay.
So that number, the 109, that is the county number, not the soil survey area ID number. Is that correct?
Right. That's
one
right.
County number.
That's the Phipps county number. So it'll be, we need the state, which that's the abbreviation for the state, and then the Phipps county number, which is the first 3 digits there. So that's very important because that enables the lab to determine if that is APHIS regulated or not, if any of those areas that Larry was talking about apply. Now down on the SSA code, that's your soil survey area code. And in some cases that will be the same as the FIPS code, but there are many soil survey areas that are multiple county areas and have a unique code. So yeah, it's important to keep those different, and it's important to put the county FIPS code in that PED-ON ID.
Okay, Steve, it says the field number is the sequential number for the whole project, not the county or soil survey area. Is that right?
That's right. That's right. And again, project means the group of samples that you submit at one time. So, you know, you go out to your first pit, you sample 6 horizons, it's 1 through 6. You go to your second pit, you sample 6 more, it's 7 through 12, and so on.
Now, on this example, field number 6, should that have a bottom depth on it?
Yeah.
Yes, it should. Yes. Yeah, that's just an oversight, but it should have a bottom depth. What will happen is if you put a bottom depth in that, it's going to auto-populate the top depth of the next row, but that's not important.
Now, this question has to do with subsampling. So, what horizon thickness do you want us to start subsampling? In the past, we've used 25 centimeters.
50 is,
Yeah.
if you have a horizon that is deeper than 50 centimeters or thicker than 50 centimeters, you should split it for sampling purposes.
And if for some reason you want to, if you see some reason to do even less than that, that probably would be okay.
That's fine. If you have a slashed horizon and you want to sample the 2 parts separately, you can enter a couple of them with the same depths there.
So a clarification again on
Field number.
these field sample IDs. So the field sample ID in the new NRCS tables do not necessarily correspond to field numbers on the PED-ON field sheet. Is that right?
That's right. That's a little confusing, but they're 2 totally different things.
And the numbers start over with every PED-ON.
Not ours.
Yeah. Yeah, ours don't start over within a project. It's a unique number.
Starts over with the next project.
And those are only used by the lab, so they're not applied anywhere else but by the lab. This field number that's in this first column and on your sample tag. Your NRCS field ID is different.
Yes, field sample numbers start over.
Well, horizon sequence numbers start over. But they're up in the horizon table.
Okay. People online didn't hear that. You have to let me know in the Q&A, and we'll go back to that. Okay. Since the soil survey area and county FIPS are not always the same, can the user PED-ON ID be different than the site ID in order to reflect the soil survey area in site?
I have seen it.
Yes, you can. It's preferred that they be the same, and it gets confusing. But they don't. And conceivably, you can have one site with more than one PED-ON ID.
Okay, that's cleared up. Next is for Ellis. The weight less than 20 millimeters is the weight of the entire bulk sample bag, right? Not just the coarse frags from 2 millimeters to 20 millimeters?
Correct. When that is sieved, you weigh everything less than 20, which includes the fine earth. You also weigh the 20 to 75. So you have 2 weights, and it's everything 20 and less for the first value.
Okay, and then a part to this is why, when you hover over that column, does it say the water content is determined in the lab? I thought yesterday's webinar they said to leave the bag open to dry before shipping. Can you kind of clarify if that's that moist sample?
Okay. On the on a normal setting where it isn't soupy, we will do the water on the bulk bag. We get a weight coming in, but you can't depend on it too well, particularly when it's something that's very high in water. And so we will assume that the 20 to 75 or 20 to 76 isn't influenced by the water too much. There will be, frankly, some fine earth stuck to it, but we will assume not much there. And the other one we will correct based on what we have in the bag. It's not an issue unless you have something with free water. There, I don't really know a good way to handle it.
And then a follow-up, they're wondering, should it read water content is determined in the lab, so seal the bag well?
We always suggest you staple them shut. It isn't perfect, and the stapling certainly is not sufficient to hold against free water in the bag.
Right. And if you do have a wet soil or soil with free water, if you'll let that bag set for 30 minutes or so and decant that off before you staple it, that'll go a long way in getting it. So if you can decant off any free water, that's helpful.
Well, there is a water correction that has to be done on this calculation. That's the problem.
Yeah, free water is just a problem with shipping. I mean, if it was important to know total water content of what it was, you know, you probably want to measure in the field somehow, but it's just impractical to ship samples that are full of water. We're going to run into packaging problems.
So, Ellis, another question on this is having to do with specifying the analyses to run. Our sampling will be for neon, so do I still need to specify? I assume it's a specific set of analyses for neon.
For any of the outside or special projects, there is a suite of analyses that was agreed to in the contract. Neon is one of those. You don't need to send anything on analytical requests in for neon as long as you're not after other properties that wouldn't normally be measured. In other words, I will apply a neon sampling request suite to all of those samples, whether you send any requests or not. EPA will be similar, incidentally.
Okay, there are some soils where we are unclear if there's enough fiber to be an O-horizon. Would it make more sense to request fiber count, PSDA, or both?
For ones where you're unsure of the amount of fiber, what we would probably do here is run loss on ignition and take a look at the results from that and decide whether to run fiber or run PSDA. The loss on ignition, incidentally, shows up in that form as mineral content or something. It's to the column to the right of fiber.
Here's a question for Larry or maybe anybody else, but so you went over all these prohibited areas, sending in samples, but where do people from areas that are quarantined go to test their samples? And how can we then determine if they are not spreading the pathogens where they go elsewhere in the U.S.? I guess I have my take on that, but I'll let you answer.
Well, if you're in a quarantine area, I think, I wish Rich was here right now because you are here, aren't you? Maybe Rich needs to answer that, but you can go within state, can't you, Rich?
Move samples around within the state?
Yeah.
It depends.
Yeah.
For instance, in California, let's say this Phytophthora ramorum quarantine, a sudden oak death, I believe, though I'm not for sure, there are restrictions on moving samples within the state, especially from the APHIS quarantine area to counties outside of that. So you would need to check with the State Department of Agriculture in your state to find out for sure. APHIS only controls the interstate movement. That's what their legislated mandate is to do. They don't do any. They don't have anything to say about intra-state movement of samples. So,
but the quarantine that we have in California for Phytophthora ramorum, there we do have a lab in California that can heat treat those and make them, and after they've been heat treated and documented by APHIS, we can receive those samples.
Yeah, there's a facility in Arcata, and we have an NRCS employee with a compliance agreement and the appropriate facility to sterilize such samples. And so if you're sampling in that part of the country, as long as, I'm pretty sure that as long as you move those samples within that quarantine up to Arcata and don't go outside the quarantine, you know, that's fine. And then those samples would be sterilized there. It's a low temperature process, so it doesn't impact, you know, some of the more volatile forms of carbon or the morphology as much as the high temperature treatment regimes would. And once those are sterilized, those samples can be shipped to this facility under a certificate. So, yeah. But if you have any questions about intra-state movement, you need to, and you don't want, and you're concerned you might be violating some rule, you need to check with your Department of Ag there. Does that answer the question? Yeah.
Back to the field numbers. Is sequence number the same as the field number?
Where specifically are you talking about the sequence number?
Within a PET-on? Maybe?
Okay, yeah. Horizon number for the first PET-on is the same as you see here, but after the first PET-on, the field numbers will continue with 7, 8, 9, 10, etc. So sequence within a project or a group of samples that's sent in at one time is the field number.
The sequence number, I might have referenced that when I was labeling the bulk or the bulk density box. But the sequence number within a PET-on would be what that horizon number is there on that PET-on sheet, 1, 2, 3, 4, 5, and 6. And so, you know, we could label, and that's the way we label. That's the way we put them in limbs. We put sequence numbers within a horizon or within a PET-on for every horizon.
But for the clod box, they're going to number the corresponding number on that lid with the horizon and the depth of the
they can get that all in there
itself. Yeah.
Yep.
Another issue in here, people are saying they're having trouble getting to the site that has the KSSL PET-on field sheets. Can you provide that path again?
Oh, okay.
May put that up for people to see.
Right. And it was working this morning. Okay, there's the actual link, which is, okay, the NRCS homepage. And this is not the USDA. If you have the USDA, you can go from it to the NRCS page, but it's www.nrcs.usda.gov. Okay, if you start at that page, if you're at the USDA page, you can find on there, it lists the agencies, and you can go from there to the NRCS page. But no, it's the one that says up at the top, our Natural Resource Conservation Service. Okay, and the topics, under topics, the blue boxes up at the top, go under topics, select soils. That will take you to the NRCS soils page. This one here. Again, you go over to the topics bar in those blue bars, you go to technical references, click on that one. It'll take you to the technical references page. Then you go down about halfway, scroll down on that page, and there's a bar that says laboratory methods and information. Okay.
And right above there, is that protocol, soil sample submission protocol for the KSSL. That's the document that I was talking about in my presentation. This is Larry. And so that tells you, I mean, it's a up-to-date document that we update every time APHIS gets updated also, and it has those precise step-by-step instructions for packing and the areas that you need to contact us if you're going to be sampling in. And it also gives documentation on how to identify the user PEDON ID, and there's lots, just about everything we talked about today is in that document.
Yeah. So, and if anybody has problems getting to this, email me or Sean or Ellis or somebody, and we can email you the link if this isn't working for you.
Larry, here's a question for you. So what's the maximum shipping weight for individual boxes? Can people just fill them up?
Well, we got to remember, I mean, the technicians in processing and receiving, we're getting kind of old. We're getting older, I should say. So, 50 pounds is probably about the, 50 pounds is probably about the maximum. We could go higher than that, but I would not recommend going over 70 pounds, and the less the better. And usually, if you have to do just one PEDON's worth of samples in one of those bags, I mean, that's quite okay.
I'm just looking through the list here. I think we got most of these. Okay, so here's one for Ellis. Do we return the 20 to 76 millimeter size back to the bag for shipment or discard?
Discard.
And just a clarification on the moist sample thing and shipment, the instruction is pour off the free water, otherwise seal it up. Everybody's nodding their head. Yes, just for those that didn't see that. Yeah.
Right. Probably you're not going to have it in the wetland soils. You're not going to have very often many fragments to deal with. Hopefully.
Now the water correction on the less than 20 is to figure out what the weight of dry soil is that matched the well, you factor down the less than 20 weight by the amount of water so that you wind up on a dry soil weight.
Right.
So it doesn't need to be sealed any different than we normally do, which is 4 or 5 staples across the top with a double fold.
Right. And if you do actually sieve it, it's probably going to lose the free water by the time you go through that sieving process anyway. Right. So it's going to be similar to what the decanted soil.
And just a clarification for our last one, Rich was talking about Arcata. Arcata will only accept samples from within California. The regional office should be informed of all samples submitted to Arcata in advance. So just a little clarification on that. Well, we've run over a little bit on today's webinar, but I appreciate everybody sticking with us. I think there were some excellent questions, got a lot of things straightened out for people, and hopefully that'll improve the paperwork that comes in and the samples that come in will get you better data. So thank you to everybody that helped with the panel webinar today, and thanks to all participants for joining in. We had well over 100 people on today's webinar. Yesterday's webinar and today's will be up on our YouTube channel early next week. So if there's something you want to review or people that didn't get to take part, just go ahead and tell them to look it up on YouTube. Thanks, everyone.
Sean?
Has left the conference.